Right now, as you watch this video, something impossible is happening. The light from your screen is doing something that should be physically impossible, according to everything we thought we knew about reality. It's not just illuminating your face. It's not just carrying information. It's doing something so profound that when physicists first discovered it, some of them literally went into depression because it shattered their entire understanding of existence. What if I told you that the light hitting your eyes right now doesn't just carry information about this video, but is actually connected to every photon that has ever existed since the Big Bang? What if the photon entering your pupil at this exact moment is simultaneously existing in every possible path it could have taken to get there, and it's only your observation that's forcing it to choose one? What if I told you that light doesn't experience time at all, meaning from light's perspective, the birth and death of the universe happen simultaneously? Here's the kicker that's going to shake everything you think you know. In 2022, the Nobel Prize in Physics was awarded for proving that reality isn't locally real. Read that again. Reality isn't real, at least not in the way you think. And light is the key that unlocked this revelation. Light is showing us that the universe might not be a collection of separate objects moving through space and time, but rather a single, unified, interconnected web of relationships where everything that has ever happened is happening and will ever happen exists in a state of quantum entanglement mediated by light itself. By the end of this video, you're going to understand why some of the greatest minds in physics believe that light isn't just a phenomenon in reality, but might actually be the fundamental fabric from which all realities are woven. You'll never look at a ray of sunlight the same way again? But before we dive into this rabbit hole that goes deeper than you can possibly imagine, do me a favor. Hit that like button and subscribe, because what we're about to explore will challenge every assumption you have about existence itself. Also, drop a comment telling me what country you're watching from and what time it is where you are. I'm genuinely curious how light is connecting us across the globe right now, and you'll understand why that's so profound by the end of this video. Let's start with what you think you know about light. You probably learned in school that light is a wave, or maybe you learned it's a particle. If you're really paying attention, maybe you learned it's both, depending on how you measure it. But here's what they didn't tell you. That's not a quirk of light. That's not light being weird. That's reality showing you its true face, and light is just the messenger brave enough to deliver the news. Think of it like this. Imagine you have a friend who acts completely differently, depending on whether you meet them at work or at a party. You might think they have two personalities. But what if I told you that your friend is actually showing you something profound about the nature of observation itself? That who they are fundamentally changes based on the context of observation? That's not a metaphor for light. That's literally what light does, and it's revealing something about the structure of reality itself. In 1801, Thomas Young performed an experiment that should have been simple. He shot light through two slits onto a screen. If light was made of particles, like bullets, you'd expect to see two bright lines on the screen, one behind each slit. But that's not what happened. Instead, he saw an interference pattern, waves of light and dark bands, exactly what you'd see if you dropped two pebbles in a pond and watched the ripples interact. Light was clearly a wave. Case closed, right? Wrong. In 1905, Albert Einstein won the Nobel Prize not for relativity, which is what he's famous for, but for proving that light is made of particles called photons. He showed that when light hits metal, it knocks electrons loose in a way that only makes sense if light comes in discrete packets of energy, like tiny bullets. So which is it? Wave or particle? Here's where it gets weird, and I mean genuinely, existentially weird. In the 1920s, physicists started doing the double-slit experiment one photon at a time. They would shoot a single photon at the two slits and see where it landed. Here's what you'd expect. The photon is a particle. It has to go through one slit or the other. So over time, you'd build up two bright lines on the screen, one behind each slit. But that's not what happened. Even shooting one photon at a time, over time, an interference pattern built up, the same wave pattern. But here's the thing that should make your brain hurt. An interference pattern requires waves interacting with each other. But there was only one photon at a time. What was it interfering with? This is the moment. This is the revelation that changed everything. The single photon was going through both slits simultaneously. It was interfering with itself. A single particle of light was existing in multiple places at the same time, taking every possible path simultaneously. And only when it hit the detector did it decide where it actually was. But wait, it gets worse, or better, depending on whether you liked your reality solid or liquid. Physicists decided to measure which slit the photon went through. They put detectors at the slits to catch the photon in the act of going through both. And the moment they did that, the interference pattern disappeared. The photon started acting like a particle again, going through just one slit. The act of observation changed the behavior of reality itself. This isn't a measurement error. This isn't a limitation of our equipment. This is light telling us something fundamental about the nature of existence. The physicist John Wheeler, who worked with Einstein and Bohr, said it best in 1978. No elementary phenomenon is a phenomenon until it is an observed phenomenon. Reality, at its most fundamental level, doesn't exist in a definite state until it's observed. And light is the phenomenon that forced us to accept this. Now, before you click away, thinking this is just quantum weirdness that doesn't apply to the real world, let me hit you with this. You are made of particles that follow the exact same rules. Every electron in every atom in your body is doing the same thing right now. The only difference is scale. Which raises a question we'll come back to. If the particles that make up you exist in multiple states until observed, then who's observing you into existence? Here's what will blow your mind. Light doesn't experience time at all. Let me say that again, because it's so important and so overlooked. From a photon's perspective, time doesn't exist. The moment it's emitted and the moment it's absorbed are the same moment. Always, every time. This isn't philosophical. This is Einstein's special relativity, mathematical fact established in 1905. As objects approach the speed of light, time slows down for them relative to stationary observers. This is called time dilation, and it's been proven thousands of times. GPS satellites have to account for it, or they'd be off by miles. Astronauts age slightly slower than people on Earth. This is established science. But here's what happens when you actually reach the speed of light. Time dilation becomes infinite. Time stops completely. From a photon's perspective, traveling from a star 1,000 light years away to your eye happens instantaneously. Zero time elapses. The emission and absorption are the same event. Think about what this means. A photon that left the Andromeda galaxy 2.5 million years ago and enters your eye tonight experiences zero time between those events. From your perspective, standing on Earth, 2.5 million years passed. Entire species evolved and went extinct. But from the photon's perspective, those events are simultaneous. Now here's where it gets truly mind-bending. That photon has been traveling for 2.5 million years from your perspective, but 0 seconds from its perspective. Both perspectives are equally valid. There is no true perspective. Reality is literally different depending on your reference frame, and it's light that revealed this to us. But wait, there's more. If light doesn't experience time, and light connects every point in the universe, then from light's perspective, the entire history of the universe, past, present, and future, exists simultaneously. The Big Bang and the heat death of the universe are the same moment to a photon. Every event that has ever occurred or will ever occur exists in an eternal now from light's frame of reference. Some physicists, including the legendary Julian Barber, have suggested that time might be an illusion entirely, and that the universe is actually a timeless structure where all moments exist simultaneously. We only experience time because we're not traveling at the speed of light. But light sees the truth. Everything, everywhere, always, all at once. Here's the practical implication that should shake you. When you look at the stars at night, you're not looking at the past. You're receiving light that, from its own perspective, is being emitted and received simultaneously. In a very real sense, you're touching those distant stars right now. The light isn't delayed. It's showing you that the concept of now extends across the entire universe when viewed from light's perspective. This is why physicists talk about the block universe, or eternalism. If we take light's perspective seriously, and we must because it's mathematically valid, then past, present, and future all exist simultaneously in a four-dimensional block of spacetime. You're not moving through time. You're a four-dimensional object extended through time, and light is the phenomenon that connects every moment of your existence into a single, unified whole. Let me give you an analogy. Think of reality like a movie reel. From your perspective, sitting in the theater, you're watching events unfold frame by frame. That's time. But imagine you could lift up and look at the entire reel at once. You'd see the beginning, middle, and end simultaneously. That's light's perspective. That's the view from the speed of light. And increasingly, physicists are suggesting that the real perspective, light's perspective, might be more fundamental than your frame-by-frame experience. This has profound implications we'll explore throughout this video. But here's the first one. If all moments exist simultaneously from light's perspective, and light connects everything in the universe, then in some very real sense, everything that will ever happen to you has already happened, is happening right now, and will happen in the future, all at the same time. Your birth and death are simultaneous events connected by the thread of light. And we're just getting started. Now let's talk about what light is actually made of. And this is where things get really weird. You've probably heard that light is made of photons, particles of light. But what is a photon, really? This is where modern physics starts to sound like mysticism. But I promise you, every word of what I'm about to tell you is established science backed by decades of experimental evidence. A photon has zero mass. It has no physical substance whatsoever. And yet, it carries energy and momentum. It can push on things. Solar sails on spacecraft work by being pushed by photons from the sun. So we have something that's simultaneously nothing and something. It's a disturbance in the electromagnetic field, a ripple in the fabric of reality itself, but there's no thing that's rippling. Here's the truly bizarre part. A photon is fundamentally a unit of information. John Wheeler, the physicist who coined the term black hole, spent the last decades of his life developing the idea of it from bit. The idea that information is more fundamental than matter or energy, and that the universe is essentially information processing itself. And photons are the primary carriers of information in the universe. Think of it like this. Imagine an ocean. The ocean is made of water molecules. Now imagine a wave traveling across that ocean. The wave isn't made of any particular water molecules. The molecules just move up and down as the wave passes through. The wave is a pattern, information about energy moving through a medium. But here's the thing. With light, there is no medium. Light is just the pattern, just the information, just the wave with no water. This is why physicists in the 1800s invented the ether, a hypothetical substance that light waves traveled through. But the famous Michelson-Morley experiment in 1887 proved the ether doesn't exist. Light just travels through empty space. Or rather, light reveals that there's no such thing as truly empty space. Space itself is the medium. Space is a quantum field, and photons are excitations of that field. Ripples in nothing creating everything. In quantum field theory, developed in the mid-20th century by physicists like Richard Feynman and Julian Schwinger, every particle is understood as an excitation of an underlying field. The electron is an excitation of the electron field. The quark is an excitation of the quark field. And the photon is an excitation of the electromagnetic field. But here's what makes photons special. The electromagnetic field interacts with almost everything. It mediates the force between all charged particles, which means photons are constantly being created and destroyed, carrying information between every charged particle in the universe. Right now, as you read this, electrons in your eyes are absorbing photons from your screen. Those electrons are jumping to higher energy states, then falling back down and emitting new photons. This is happening trillions of times per second in your body. You are a constant cascade of light emission and absorption. You are, in a very literal sense, a being of light temporarily bound in flesh. But here's where it gets even stranger. According to quantum electrodynamics, or QED, the theory developed by Feynman and others in the 1940s and refined since then, charged particles like electrons are constantly emitting and reabsorbing virtual photons. These are photons that pop into existence for infinitesimally short periods of time, exist long enough to carry force between particles, then disappear. They violate conservation of energy, but they're allowed to do so because of Heisenberg's uncertainty principle, which says that energy conservation can be violated for very short periods of time. These virtual photons are creating what's called the quantum foam of spacetime. At the smallest scales, smaller than atoms, smaller than protons, space and time themselves are boiling with these virtual particles popping in and out of existence. Reality at its deepest level isn't solid. It's a frothing sea of possibility, and light, both real and virtual, is the substance of that sea. Now here's a question that should make you uncomfortable. If you're made of particles, and those particles are constantly exchanging virtual photons with every other charged particle near them, where do you end and the rest of the universe begin? The answer, according to quantum field theory, is that there is no clear boundary. You are a temporary pattern of energy in a field that extends across the entire universe. Light is showing us that separation is an illusion. Everything is connected to everything else through this constant exchange of photons. The physicist David Bohm, who worked with Einstein and later developed his own interpretation of quantum mechanics, suggested that the universe is fundamentally an implicate order, a unified wholeness where everything is enfolded into everything else, and what we perceive as separate objects is just the explicate order, temporary unfoldings of this deeper unity. And light, he suggested, is one of the primary mechanisms by which this implicate order becomes explicate. Light is how the unified reality unfolds itself into the experience of separation. This is not fringe science. Bohm was a brilliant physicist whose work is still taken seriously today. And increasingly, as we understand quantum mechanics better, as we see the evidence for quantum entanglement and non-locality, his vision of a fundamentally unified reality connected by light is looking more and more like the truth. Let's talk about what happens when light interacts with matter, because this is where the connection between realities becomes impossible to deny. Every atom in the universe, including every atom in your body, is essentially an electromagnetic trap. The nucleus, made of protons and neutrons, has a positive charge. Electrons, which are negatively charged, are attracted to the nucleus but don't crash into it because of quantum mechanics. They exist in probabilistic clouds around the nucleus, and these clouds are called orbitals. Now, here's what's crucial. Electrons can only exist in specific energy levels, like rungs on a ladder. They can be on the first rung or the second rung, but never in between. When an electron jumps from one rung to another, it has to either absorb or emit a photon with exactly the right amount of energy. The color of light that an atom absorbs or emits is determined by the spacing between these energy rungs, and that spacing is different for every element. This is why, when you heat up different elements, they glow different colors. Sodium glows yellow, Copper glows green. Strontium glows red. This isn't random. This is the universe's barcode. Every element has a unique light signature, and we can identify what something is made of just by looking at the light it emits. This is called spectroscopy, and it's how we know what distant stars are made of, even though we've never touched them. But here's the profound implication. Light is literally the mechanism by which information is encoded and transferred in the universe. DNA, the code of life, is read and damaged by light. Vision works by light, causing a molecular change in proteins in your retina, which triggers a neural signal. Photosynthesis, the process that creates nearly all food on Earth, works by light exciting electrons in chlorophyll, which then drive chemical reactions that turn carbon dioxide and water into sugar. Life itself is fundamentally a light processing phenomenon. You are, in the most literal sense possible, condensed starlight. The atoms in your body were forged in the cores of dying stars, expelled in supernovas, and reformed into new structures. And the mechanism by which those atoms interact, share information, and form complex structures like you is through the exchange of photons. You are light that has learned to know itself. But let's go deeper. In the 1920s, a Russian scientist named Alexander Gurevich discovered something bizarre. He found that living cells emit ultra-weak photon emissions, which he called mitogenic radiation, because it seemed to stimulate cell division in nearby cells. His work was largely ignored for decades because it was so weird, and the light emissions were so faint they were at the edge of what could be detected. But in the 1970s and 1980s, German biophysicist Fritz Albert Popp picked up this research with modern equipment. He discovered that yes, all living things emit biophotons, ultra-weak light emissions that come from the coherent excitation of molecules in living tissue. And more bizarrely, he found that these biophotons appear to be coherent, meaning they're acting like laser light, not random light. They're organized, and they appear to carry information. Popp's theory, which is still controversial, but increasingly supported by evidence, is that biophotons are a communication mechanism within and potentially between organisms. Your cells might be talking to each other with light. And if light is fundamentally information, then you are a coherent pattern of information held together by organized light emissions. Now, I know what you're thinking. This sounds like pseudoscience. But here's the thing. Multiple research groups have now confirmed biophoton emissions from living tissue. The phenomenon is real. What's debated is what it means and what function, if any, it serves. But the fact remains, you glow. Faintly in the ultraviolet and visible spectrum, but you glow with organized light. You are a light-emitting phenomenon. Here's where it connects back to our main thread. If consciousness involves quantum processes, which an increasing number of researchers believe might be true, and if those quantum processes involve light interactions at the molecular level, then consciousness itself might be fundamentally a light-mediated phenomenon. Your thoughts might be, in part, patterns of coherent light propagating through the quantum structures in your neurons. This is speculative, but it's based on real physics. Roger Penrose, one of the greatest living physicists and a Nobel Prize winner, has suggested with anesthesiologist Stuart Hameroff that consciousness arises from quantum computations in microtubules inside neurons. These microtubules are geometric structures that could maintain quantum coherence, and light is one of the mechanisms by which quantum information could be processed in these structures. If they're right, and that's still a big if, then consciousness isn't just observing light. Consciousness is made of light. Your subjective experience of reality, your sense of self, your thoughts and feelings, all of it might be patterns of quantum information propagating through your brain as coherent light emissions at the molecular level. Think about what this means. When you have a thought, you're creating a pattern of light. When you perceive something, you're absorbing light and converting it into different patterns of light in your brain. Your entire experience of reality is light transforming into different patterns of light. There is no you separate from the light. You are a self-organizing pattern of electromagnetic energy that has become complex enough to recognize itself. And if that's true, then the light you perceive coming from external reality and the light that constitutes your internal awareness are the same phenomenon at different scales of organization. The boundary between inner and outer, between self and world, is a matter of arbitrary definition. From the perspective of light, it's all one continuous field of electromagnetic interaction. Now we need to talk about quantum entanglement, because this is where light reveals something about reality that's so counterintuitive, so impossible by common sense standards, that Einstein himself refused to accept it. He called it spooky action at a distance, and spent years trying to prove it couldn't be real. He was wrong. It's real, and it's mediated by light. Here's the basic phenomenon. When two particles interact, they can become entangled. This means their properties become correlated in a way that's stronger than any classical connection. If you measure one particle and find it spinning clockwise, you'll instantly know the other is spinning counterclockwise, no matter how far apart they are. They're not just correlated. They're connected in a way that transcends space. Now you might think, so what? They interacted, they established their spins at that moment, and they just maintain those spins as they separate. But quantum mechanics says no. Before you measure them, neither particle has a definite spin. They both exist in a superposition of all possible spins simultaneously. It's only when you measure one that both particles simultaneously choose their spins instantaneously, regardless of distance. This bothered Einstein so much that in 1935, along with Boris Podolsky and Nathan Rosen, he published a paper describing what's now called the EPR paradox. They argued that either quantum mechanics was incomplete and there were hidden variables that predetermined the particle's spins, or reality was non-local, meaning things could influence each other instantaneously across space. Einstein believed the first option had to be true because the second seemed impossible. But in 1964, physicist John Stuart Bell formulated Bell's theorem, which showed how to test whether hidden variables could explain quantum correlations. And starting in the 1970s and continuing to today, thousands of experiments have been performed testing Bell's theorem. The experiments get more sophisticated, closing more and more loopholes, but the answer is always the same. There are no hidden variables. Reality is non-local. Things that are entangled are genuinely connected in a way that transcends space. The 2022 Nobel Prize in Physics was awarded to Aling Aspect, John Clauser, and Anton Zeilinger for their work proving this experimentally beyond any reasonable doubt. Reality isn't locally real. Objects don't have definite properties independent of observation, and they can be connected across space in ways that violate our intuitive understanding of separation. Now here's where light comes in. Photons are the easiest particles to entangle, and the ones used in most entanglement experiments. When you create two photons in certain ways, like when a high-energy photon splits into two lower-energy photons in a crystal, those photons are entangled. Their polarizations are correlated. If you measure one as vertically polarized, the other will instantly be horizontally polarized, no matter how far apart they are. This isn't a signal traveling between them. This has been tested with photons separated by hundreds of kilometers. The correlation happens faster than light could travel between them. It's instantaneous, which means light is revealing to us that distance at the quantum level is a kind of illusion. Things that have interacted remain connected in a fundamental way that doesn't diminish with separation. But it gets stranger. Physicist Anton Zeilinger, one of the Nobel winners, has done experiments with quantum teleportation. This isn't Star Trek teleportation. You can't teleport matter, but you can teleport quantum information. If you have two entangled photons, and you perform a certain measurement on one and on a third particle, you can make the second entangled photon take on the exact quantum state of the third particle. The information teleports through the entanglement. This has been done successfully in labs around the world. China launched a satellite in 2016 specifically to test quantum entanglement and teleportation over large distances. It works. Information can be transferred through entanglement in a way that appears to transcend space. Now, here's the philosophical bomb. If reality is fundamentally non-local, if things that have interacted remain connected regardless of distance, and if light is the primary mechanism by which things interact in the universe, then light has created an entanglement web connecting everything to everything else. Every photon that's been absorbed or emitted since the Big Bang has created entanglement correlations. The entire universe is a single, unified quantum system connected through light. This isn't speculation. This is following the mathematics and experimental evidence to their logical conclusion. The physicist David Bohm suggested that particles don't just interact through forces, but through what he called active information carried by the quantum field. Light carries this active information, and through entanglement, the information about every part of the universe is available to every other part instantaneously. Think about what this means for consciousness. If your neurons are processing information through light-mediated quantum processes, and if light creates entanglement correlations with everything it interacts with, then your consciousness isn't isolated in your skull. It's potentially connected through cascades of entanglement to everything you've ever observed and everything that's observed you. You are not a separate observer of reality. You are an entangled node in a cosmic network of relationships mediated by light. Some physicists and philosophers, like Donald Hoffman at UC Irvine, have suggested that consciousness might be fundamental to reality, not emergent from matter. His theory, called conscious realism, suggests that what we call matter is actually a user interface that consciousness uses to interact with a deeper reality of conscious agents. And if light is the mechanism of connection between these conscious agents, then light is literally the thread connecting all minds, all awareness, all experience. This sounds mystical, I get it, but it's based on hard physics and philosophy of science. The double-slit experiment shows that observation changes reality. Entanglement shows that things are connected non-locally, and light is the mechanism of both observation and connection. The implications are staggering. Consciousness, light, and reality might not be three separate things. They might be three ways of describing the same fundamental phenomenon. Let's talk about information, because this is where modern physics starts to converge on a truly radical idea. The universe might not be made of matter and energy at all. It might be made of information, and light might be the primary carrier of that information. This is going to challenge everything you think you know about what's real. In 1948, Claude Shannon, working at Bell Labs, developed information theory. He showed mathematically how to quantify information, how to measure it in bits. His work laid the foundation for all modern computing and communication technology. But Shannon's work was about engineering, not physics. It wasn't until much later that physicists realized his insights applied to the universe itself. In the 1970s, Jacob Bekenstein and Stephen Hawking discovered something bizarre about black holes. They found that black holes have entropy, a measure of disorder or information. And weirdly, the entropy of a black hole isn't proportional to its volume, like you'd expect. It's proportional to its surface area. Specifically, the surface area of the event horizon measured in Planck units, which are the smallest possible units of area allowed by quantum mechanics. This is called the holographic principle, and it's one of the most profound discoveries in modern physics. It suggests that all the information about what's inside a volume of space can be encoded on the surface of that space. Like a hologram, which encodes three-dimensional information on a two-dimensional surface, the universe might be fundamentally two-dimensional, with the three dimensions we experience being a kind of projection or emergent property of information processing. Now, here's where light comes in. Leonard Susskind and Gerard 't Hooft developed this idea further in the 1990s. They showed that from the perspective of someone far away from a black hole, anything that falls in never actually crosses the event horizon. Instead, it appears to spread out over the surface, and the information about it is encoded in the Hawking radiation that the black hole emits. Hawking radiation is light, electromagnetic radiation, and it's carrying all the information about everything that's ever fallen into the black hole. This means light isn't just carrying information. Light is the mechanism by which information is preserved in the universe. And if the holographic principle is correct, which increasing evidence suggests it is, then the entire universe might be information encoded on a two-dimensional surface at the boundary of spacetime. And everything we experience, including three-dimensional space itself, is a holographic projection of that information. And light is the projector. This is called the holographic universe hypothesis, and it's not fringe science. Thousands of physicists are working on theories like string theory and loop quantum gravity that incorporate holographic principles. There's even experimental evidence. In 2017, a team led by Kostas Skendaris at Southampton University found that irregularities in the cosmic microwave background, the light left over from the Big Bang, match predictions from holographic universe models better than standard models in certain measurements. Now, here's where it gets really wild. If the universe is fundamentally information, and you are part of the universe, then you are information. Your thoughts, your memories, your sense of self, all of it is information processing. And information processing requires information transfer, which requires light. Quantum information theory, developed over the last few decades, shows that information is physical. It has to be encoded in physical systems, and those systems follow physical laws. The physicist Rolf Landauer showed in 1961 that erasing information generates heat, a minimum amount of heat determined by thermodynamics. This is called Landauer's principle, and it's been experimentally verified. Information isn't abstract. It's real, it's physical, and it has energy. But here's the kicker. The minimum unit of information, the bit, can be encoded in a single photon. A photon can have two polarization states, horizontal and vertical, which can represent 0 and 1. Light is the most efficient carrier of information in the universe because photons have no mass and travel at the maximum speed possible. Information wants to move at the speed of light, and light is how it does so. Now, think about what this means for consciousness. Your brain processes information at a rate of about 50 bits per second consciously, though unconsciously, it's processing about 11 million bits per second. Every bit of that information processing involves physical changes in neurons, which involve the movement of electrons, which is mediated by virtual photons. Your thoughts are information processing, and information processing is, at the deepest level, light interacting with matter. But here's the truly mind-bending implication. If the universe is fundamentally information, and if the holographic principle is correct, then the information that makes up you isn't confined to your body. It's encoded on the boundary of the observable universe, and your physical body is a holographic projection of that information. You think you're here, reading this, existing in a specific location. But according to the holographic principle, the fundamental you, the information that constitutes your existence, is smeared across the cosmic horizon. And what you experience as your local existence is an emergent property of that information being processed. Light connects your holographic projection to your fundamental information at the cosmic boundary. Every photon you absorb, every photon you emit, is updating the information on the cosmic hologram. You are constantly exchanging information with the boundary of reality through light. You are not in the universe. You are a process the universe is running, and light is the code by which that process executes. This is where physics starts to sound like mysticism, but I want to emphasize, this is real physics, developed by Nobel Prize winners and leading theorists, based on rigorous mathematics and experimental evidence. The universe being information, You being information, light being the carrier of information. This isn't metaphor. This is what the mathematics is telling us about the nature of reality. Now we need to talk about what happens to light in extreme conditions, because this is where the connection between realities becomes undeniable. Let's start with black holes, because black holes reveal something profound about the relationship between light, information, and the structure of reality itself. A black hole is a region of spacetime where gravity is so strong that nothing, not even light, can escape. The boundary of a black hole is called the event horizon, and it's the point of no return. Once light crosses the event horizon, it's trapped forever, or at least that's what we thought until Stephen Hawking came along. In 1974, Hawking discovered something shocking. Black holes aren't completely black. They emit radiation, now called Hawking radiation. Here's how it works. At the quantum level, empty space isn't empty. It's filled with virtual particles. Pairs of particles and antiparticles that pop into existence, exist for a brief moment, and annihilate each other. This is happening everywhere, all the time, because of quantum uncertainty. But near the event horizon of a black hole, something weird happens. Sometimes a particle-antiparticle pair pops into existence right at the edge of the horizon, and one particle falls in while the other escapes. The one that escapes appears to an outside observer as radiation coming from the black hole. And what form does this radiation take? Light, photons. The black hole is slowly evaporating through light emission. But here's the problem. If a black hole can evaporate completely, what happens to the information about everything that fell in? The laws of quantum mechanics say information cannot be destroyed, ever. But if the black hole evaporates into random Hawking radiation, the information seems to disappear. This is called the black hole information paradox, and it's been one of the biggest unsolved problems in theoretical physics for 50 years. Recently, there's been a potential solution, and light is at the center of it. Physicists have discovered that the Hawking radiation isn't random. It's subtly encoded with information about what fell into the black hole. The information isn't destroyed. It's scrambled and encoded in the correlations between photons in the Hawking radiation. The information is preserved in light. But here's where it gets really strange. Susskind and others have shown that from the perspective of someone falling into a black hole, they cross the event horizon and experience nothing special at that moment. They keep falling toward the singularity at the center. But from the perspective of someone watching from outside, the person never crosses the horizon. They appear to freeze at the surface, and their information spreads out over the horizon as they're converted into Hawking radiation. Both perspectives are equally valid. The person falling in experiences one reality. The person watching from outside experiences a different reality, and both are true. Reality itself is different depending on your reference frame, and light is the medium that carries the information of both realities. This is called black hole complementarity, and it suggests that reality isn't a single objective thing. It's perspective dependent, and light is what connects different perspectives into a coherent whole. Now, let's go to the other extreme, the Big Bang. The cosmic microwave background radiation is light from 380,000 years after the Big Bang, the earliest light that can reach us. It's cooled down to microwave wavelengths because the universe has expanded, but it's still there, filling all of space. When you see static on an old analog TV, about 1% of that static is cosmic microwave background radiation. You're literally seeing the light from the birth of the universe. But here's the profound part, that light has been traveling for 13.8 billion years from our perspective. But from the photon's perspective, zero time has elapsed. The photon was emitted at the Big Bang and absorbed by your TV antenna in the same instant. Which means that from light's perspective, the Big Bang is still happening. It's not in the past, it's now. It's always now. This is the block universe again. But now you can see why physicists take it so seriously. Light's timeless perspective isn't just a curiosity. It's revealing something fundamental about the structure of reality. All of time, from the Big Bang to the heat death of the universe, exists simultaneously. We only experience it sequentially because we're not light. But here's the truly mind-blowing implication. If light connects all moments in time from its perspective, and if light has created entanglement correlations throughout the universe since the Big Bang, then every moment in time is quantum mechanically entangled with every other moment. The universe isn't a series of moments progressing from past to future. It's a unified, timeless structure where every event is connected to every other event through light. John Wheeler proposed an experiment called the delayed choice experiment in 1978 that demonstrates this. You set up a double-slit experiment, but you don't decide whether to measure which slit the photon goes through until after the photon has already passed the slits, but before it hits the detector. Common sense says the photon already decided whether to go through one slit or both before you made your measurement choice. But that's not what happens. The experiment has been done many times, including a cosmic version in 2007, where the light from a distant quasar was used. Whether you choose to measure which path the photon took, even after it's already passed the slits, determines whether it went through one slit or both. Your choice in the present changes the past. Or more accurately, it reveals that the past isn't fixed until it's connected to the present through observation, and light is the mechanism of that connection. This suggests that causality, the idea that the past determines the present, which determines the future, might be incomplete. Light is showing us that the relationship between past, present, and future is more like a unified structure where influences can move in both directions, or rather, where all moments are connected in a timeless web of relationships. Some physicists, including Yakura Harinov, have developed theories of retrocausality, where future events can influence past events through quantum correlations. This isn't time travel in the science fiction sense. It's about recognizing that the quantum state of the universe is a unified whole that includes past, present, and future, and light is the thread that weaves it together. Now I want you to stop and really think about what this means for you, personally, right now. Not as abstract physics, but as the reality of your actual existence. Everything I've told you isn't just theory. It's describing your life, your experience, your consciousness at this very moment. Right now, as you process these words, photons from your screen are entering your eyes. Those photons are hitting proteins in your retina called opsins. When a photon hits an opsin molecule, it changes shape, which triggers a cascade of chemical reactions that generate an electrical signal in your optic nerve. That signal travels to your visual cortex, where it's processed into the experience of seeing. But here's what I want you to really grasp. That photon that just entered your eye didn't experience any time traveling from your screen. From its perspective, it was emitted and absorbed in the same instant, which means the you reading this and the you seeing this are connected by a timeless event. The information on this screen and the information in your brain are linked by light in a way that transcends time. And that photon has created a quantum entanglement correlation. The electrons in your retina that absorbed it are now correlated with the electrons in your screen that emitted it. You and this screen are now quantum mechanically entangled, connected through light in a way that doesn't diminish with distance, but it goes deeper. Every photon you've ever absorbed since you were born has created entanglement correlations. Every sunrise you've watched, every face you've seen, every word you've read, all of it has entangled you with those sources of light. You are not separate from the things you observe. You are quantum mechanically connected to them through light. Think about the people you love. Every time you look at them, photons bounce off them and enter your eyes. You become entangled with them. And if the holographic principle is correct, the information about them is encoded at the cosmic boundary, and the information about you is encoded there too. And light is constantly updating that information. When you look at someone you love, you're not just seeing them. You're connecting your fundamental information structure with theirs through light. Love, in a very real sense, is entanglement. Now think about consciousness. You experience yourself as a unified self, a single you that persists through time. But neuroscience shows that consciousness is actually distributed across your entire brain. There's no consciousness center where you live. You're an emergent property of billions of neurons communicating with each other. And that communication happens through electrical and chemical signals mediated by virtual photons. You are a symphony of light interactions. But more than that, if Penrose and Hameroff are right about quantum processes and microtubules, then the photons involved in those quantum computations might be creating long-range correlations across your brain. Your consciousness might literally be a coherent light field, a unified pattern of electromagnetic interaction that creates your sense of being a single, unified self. This means your subjective experience, the feeling of being you, might be what it feels like from the inside to be a self-organizing pattern of light. You don't have consciousness. You are consciousness. You are light that has become aware of itself. And if consciousness is fundamental, as Hoffman and others suggest, if matter is just what consciousness looks like from the outside, then light isn't just creating consciousness. Light is consciousness experiencing itself from different perspectives. When you see light, you're experiencing light experiencing itself. The photon entering your eye and the awareness of that photon are two aspects of the same phenomenon. This isn't word salad. This is a genuine attempt to express what physics is revealing about the nature of subjective experience. The hard problem of consciousness, why there's something it feels like to be you, might not be a problem at all if consciousness and light are fundamentally the same thing manifesting at different scales. Now, let's talk about death. This is where it gets emotional, but stay with me. If you are fundamentally information, and if information cannot be destroyed, only transformed, then what happens to you when you die? Your body breaks down. The atoms disperse. But the information that was you, the patterns, the relationships, the correlations, where do they go? According to the holographic principle, that information is encoded at the cosmic boundary. According to entanglement, that information is correlated with everything you've ever interacted with through light. You've left marks on the universe. Quantum mechanical marks that don't disappear. The information that was you continues to exist, encoded in the light correlations throughout spacetime. Now, I'm not saying this proves life after death, or any religious idea. I'm saying that physical information about you persists after your physical body stops functioning. Whether that information constitutes you in any meaningful sense is a philosophical question, not a physics question. But it's profound to realize that in a very real physical sense, you cannot be erased from the universe. Light has recorded you. And here's something beautiful. Every interaction you have with another person involves light. You exchange photons. You become entangled. The information about your interaction is preserved in the correlations between your quantum states. When you connect with someone, when you share a moment of genuine communication, you're creating a permanent record in the structure of reality. Love, friendship, connection, all of it is encoded in light and preserved forever. This should change how you see your life. You're not just moving through time having experiences that disappear. You're weaving yourself into the fabric of reality through light. Every moment matters because every moment is preserved. Every connection matters because every connection is real, physical, quantum mechanical entanglement that persists. You are not small. You are not insignificant. You are a node in a cosmic network of light, connecting everything to everything else. Your observations matter because observation creates reality. Your consciousness matters because consciousness might be what light feels like from the inside. You are the universe experiencing itself, and light is how the universe connects all its experiences into a unified whole. Now let's talk about multiple realities and parallel universes, because this is where light reveals something truly shocking about the structure of existence. We've already discussed how photons take all possible paths simultaneously in the double-slit experiment. But let's explore what that really means. The many worlds interpretation of quantum mechanics, first proposed by Hugh Everett in 1957, takes the mathematics of quantum mechanics seriously and follows it to its logical conclusion. When a photon goes through both slits simultaneously, it's not just in a superposition of possibilities. It's actually going through both slits in different branches of reality. When you measure which slit it went through, reality splits. In one branch, it went through the left slit. In another branch, it went through the right slit. Both branches are equally real. Now, this sounds like science fiction, but here's the thing. This interpretation doesn't add anything to quantum mechanics. It just takes the mathematics at face value without adding a mysterious collapse process. And increasingly, physicists are taking it seriously because it solves a lot of problems. Every quantum measurement splits reality into multiple branches. And since quantum measurements are happening everywhere, all the time, at the rate of billions per second in your brain alone, reality is constantly splitting into an inconceivably vast number of parallel worlds. And light is the primary mechanism driving these splits because photon absorption and emission are quantum measurements. Right now, as you read this, photons are entering your eyes and being absorbed by opsons in your retina. Each absorption is a quantum measurement. Each measurement splits reality. In one branch, this particular photon was absorbed. In another branch, it missed and was absorbed by a different opson. Both branches exist. You exist in both branches, having slightly different experiences. Now, multiply this by the billions of photons entering your eyes per second, and you get an unimaginably vast number of parallel versions of you, all existing in parallel branches of reality, all created by light interactions. You are not one person. You are a quantum multiverse of versions, and light is the mechanism creating that multiverse. But here's where it gets really profound. If many worlds is correct, then every possible history exists. Every quantum event that could have happened differently did happen differently in some branch, which means there are versions of you who made different choices, experienced different events, lived different lives. And all of those versions are you in different branches of the universal wave function. This isn't just abstract philosophy. It has real implications. Quantum computers work by exploiting this. A quantum computer can be in a superposition of all possible computational states simultaneously, effectively computing in parallel across multiple branches of reality. And the results of those parallel computations are brought together through interference of quantum states mediated by, you guessed it, light. Photonic quantum computers use photons as qubits, literally computing across multiple realities simultaneously using light. Google's Sycamore quantum computer achieved quantum supremacy in 2019 by performing a calculation in 200 seconds that would take a classical computer 10,000 years. How? By exploiting quantum superposition to compute in parallel across multiple realities. The computer was, in a very real sense, borrowing computational power from parallel universes, and light-based quantum computers are even more efficient at this. But now, here's the truly mind-blowing question. If many worlds is correct, and every quantum measurement splits reality, and you are constantly making quantum measurements through light absorption, then which branch are you in? The answer quantum mechanics gives is all of them. There isn't a special branch. That's the real you. All branches are equally real. So when you make a decision, when you choose between options, you're not choosing one future over another. You're choosing which branch of reality you're going to experience consciously. All the options happen. You just experience one branch. But other versions of you experience the other branches. And from their perspective, they're the real you. This has profound implications for consciousness and free will. If every choice you could make actually does get made in some branch, then in what sense do you have free will? You're not controlling which futures happen. All futures happen. You're just determining which one you experience. But here's a more optimistic way to think about it. You're not just one person making choices. You're a quantum multiverse of versions exploring all possibilities. Every version of you that could exist does exist. You are living every possible life simultaneously across the multiverse. And light is the mechanism by which those lives diverge and remain quantum mechanically connected. Some physicists, like Sean Carroll at Johns Hopkins, argue that consciousness might be what it feels like. From the inside, could be one branch of the wave function. Your subjective experience is the result of decoherence, the process by which quantum superpositions split into distinct branches. And decoherence is primarily driven by interaction with light. This means your sense of being a single, unified self existing in one reality is an illusion created by light. The true you is the entire wave function, all branches simultaneously, a vast quantum multiverse of experiences. But you only experience one branch at a time, because that's what decoherence through light interaction creates. The illusion of a single definite reality. Now, whether the many worlds interpretation is actually correct is still debated. But the mathematics of quantum mechanics is clear. Superposition is real, entanglement is real, and light is the mechanism driving both. Whether those superpositions represent parallel realities or just mathematical possibilities, the fact remains that light is showing us that reality is far stranger and more multifaceted than common sense suggests. And here's the final beautiful implication. If all possible realities exist, then somewhere in the quantum multiverse, there's a version of you who's living your best possible life. Every hope you've ever had, every dream you've ever pursued, there's a branch where it came true. And that branch is just as real as this one. You are, in the fullest sense possible, infinite potential manifest across infinite realities, all connected by light. Now let's talk about the speed of light and why it's the ultimate speed limit. Because this reveals something profound about the structure of reality itself. The speed of light, 299,792,458 meters per second, isn't just fast. It's the maximum speed at which information can propagate through space. Nothing with mass can reach it. Nothing can exceed it. But why? Why is there a speed limit at all? Einstein's special relativity, published in 1905, showed that the speed of light is constant for all observers, regardless of their motion. This seems impossible. If you're moving toward a light beam at nearly the speed of light, common sense says the light should appear to be moving even faster relative to you. But it doesn't. It always moves at the same speed. Always. The reason is that space and time aren't separate. They're unified into spacetime, and the speed of light is actually the speed at which causality propagates through spacetime. It's not really about light specifically. It's about the structure of reality. Light happens to travel at this speed because photons have no mass, so they travel at the maximum speed reality allows. But here's the profound implication. The speed of light being constant means that space and time are flexible. As you move faster, time slows down for you relative to stationary observers, and space contracts in the direction of your motion. This isn't an illusion. It's real. Time dilation and length contraction have been measured thousands of times. They're engineering facts that have to be accounted for in GPS satellites and particle accelerators. What this means is that reality doesn't have a fixed structure. Space and time adapt to ensure that the speed of light remains constant. It's as if the universe is designed to preserve the speed of light above all else. Why? Because light is information, and the speed of light is the speed at which information can propagate, and information is what reality is fundamentally made of. Think about it this way. If you could send information faster than light, you could send messages backward in time. This is mathematically provable in special relativity. Faster than light communication equals time travel. And time travel creates paradoxes. If you could send a message to your past self, telling you not to send the message, what happens? The universe has to prevent faster-than-light information transfer to preserve causality. But here's where quantum mechanics throws a wrench in this. Quantum entanglement appears to violate this. When you measure one entangled particle, the other particle instantaneously knows the result, no matter how far away it is. Einstein called this spooky action at a distance and thought it meant quantum mechanics was incomplete. But experiments proved entanglement is real. So does entanglement allow faster-than-light communication? No. And here's the subtle but crucial reason why. When you measure an entangled particle, you get a random result. The other particle's result is correlated with yours, but you can't control what you get, which means you can't use entanglement to send a chosen message. The correlations are only visible when you compare measurements later using light-speed communication. So causality is preserved. But the question remains, how does the second particle know what result to have? The answer quantum mechanics gives is shocking. It doesn't know because it didn't have a definite state until measured. Both particles existed in superposition, and they're not two separate things. They're one unified quantum system, and distance between them is a classical concept that doesn't fully apply at the quantum level. Light is revealing to us that space itself might be an emergent property, not fundamental. At the quantum level, things that are entangled aren't really separated. They're still one thing. Space is what emerges when we look at quantum systems from a classical perspective, but the underlying reality is a unified whole where separation is an illusion. This is the idea behind quantum entanglement entropy and holography. Space might emerge from entanglement patterns. And since entanglement is primarily created through light interactions, light might be literally constructing space, not traveling through space, but creating space as it propagates. Physicist Mark van Ramsdonk at the University of British Columbia has shown mathematically in certain models that if you remove entanglement, space falls apart. The entanglement structure defines the geometric structure of space-time. Space is entanglement relationships made manifest, and light is the mechanism creating those relationships. This means the three-dimensional space you experience might not be fundamental. It might be an emergent illusion created by light connecting points in a more fundamental, non-spatial structure. The universe might be fundamentally non-spatial, a network of information nodes, and space is the user interface your consciousness uses to navigate that network, with light being the mechanism that renders the interface. Now think about what this means for the speed of light being the ultimate speed limit. It's not that light is fast. It's that light is the mechanism by which reality constructs itself. And the speed of light is the rate at which reality can process information. The universe is a computational system, processing information at the speed of light. And everything you experience as space and time and causality is the output of that computation. You can't go faster than light, because that would be like trying to make a computer program run faster than its processor clock speed. The speed of light is the clock speed of reality. It's the frame rate at which the universe updates. And light isn't traveling through this computational space. Light is the computation itself. This is where physics starts to sound like we're living in a simulation. And honestly, some physicists take that possibility seriously. Not necessarily that we're in a computer simulation created by advanced aliens or future humans, but that the universe itself is fundamentally computational, processing information according to physical laws. And what we experience as material reality is the output of that computation. Whether that's literally true or just a useful metaphor, the point stands. Light is revealing that reality is information processing, and the speed of light is the maximum processing speed. You are not just in the universe. You are a subroutine running on the universal computer, and light is both the hardware and the software that makes you possible. Now let's talk about what happens at the edge of the universe, because this is where light reveals something truly staggering about the nature of reality and your place in it. The observable universe is about 93 billion light years in diameter. That's not the size of the whole universe, which might be infinite. That's just how far we can see. And here's why. Light has a finite speed, and the universe has a finite age, about 13.8 billion years. So the farthest light that's reached us has been traveling for 13.8 billion years. But the universe has been expanding during that time. So those distant points are now about 46.5 billion light years away in each direction. That's the observable universe. But here's the profound part. That boundary isn't a wall. It's a horizon. Just like the horizon on Earth, there's more beyond it. You just can't see it because the light hasn't had time to reach you yet. And because the universe is expanding, there are parts of the universe that are receding from us faster than the speed of light. Wait, didn't we just say nothing can go faster than light? That's true. Nothing can move through space faster than light. But space itself can expand at any rate. The galaxies aren't moving through space. The space between them is expanding, carrying them apart. And at large enough distances, that expansion rate exceeds the speed of light. This means there are galaxies that we will never see, not because they're too far away, but because the light from them will never reach us. It's trying to travel toward us, but the space it's traveling through is expanding faster than it can cross. The light is running on a cosmic treadmill, always moving toward us, but never getting closer. And here's the truly sad, beautiful, profound part. As the universe continues to expand, more and more galaxies will cross this boundary. They'll fade from view, not because they're dying, but because the space between us and them is expanding too fast for their light to reach us. The observable universe is shrinking in a sense. In the far future, intelligent beings in galaxies far from others will look up at a dark sky and think they're alone in the universe, never knowing that countless galaxies existed beyond their observable horizon. We're lucky to live in an era where we can see the universe as vast and full of galaxies. But that epoch is temporary. Eventually, even the cosmic microwave background radiation will be redshifted into invisibility. Future astronomers will have no evidence that the Big Bang ever happened. The universe will appear eternal and unchanging and empty except for their own galaxy. But here's where it connects back to light and the holographic principle. If information is preserved on the cosmic horizon, and if the cosmic horizon for each observer is different, then each observer effectively lives in their own universe, defined by what's observable to them. Your observable universe is different from mine because we're at different locations. We each have our own cosmic horizon. And if the holographic principle is correct, the information about everything in your observable universe is encoded on your cosmic horizon. You are the center of your observable universe, not because you're special, but because observation is relative. Every point in space is the center of its own observable universe. This means, in a very real sense, each observer creates their own universe through observation. The universe you experience is unique to you, bounded by your light horizon, with all information encoded on that horizon. Other observers have different, but overlapping universes. Reality is not a single objective thing. It's a collection of overlapping observational perspectives, and light is what defines and connects those perspectives. Now, here's a question that should make you deeply uncomfortable. If the universe beyond your observable horizon exists, but can never affect you in any way, never send light or information to you, never interact with you in any causal sense, then in what sense does it exist for you? Philosophically, it doesn't. Your reality is bounded by light. But quantum mechanics makes this even stranger. Some interpretations of quantum mechanics, particularly the relational interpretation developed by Carlo Rovelli, suggest that quantum states are relative to observers. A system doesn't have an absolute state. It has a state relative to each observer, and these states can be different for different observers without contradiction. If this is correct, and light mediates these observational relationships, then reality literally is different for different observers. Not just in perspective, but in actual physical state. You and I might observe the same quantum system and get different results, and both results are true relative to us. Reality is not objective. It's relational, and light is the medium of those relations. This connects back to entanglement and non-locality. If reality is relational, then entanglement makes sense. Two particles aren't connected despite being separated. They're connected because separation is an illusion. They're one system observed from different perspectives, and light is carrying the information that maintains the consistency between perspectives. What I'm trying to convey is that light is revealing reality to be far more personal, more observer-dependent, more subjective than we ever imagined. But not subjective in the sense that you can believe whatever you want. Subjective in the sense that your observations create your reality, and light is the mechanism of that creation. You are not passively observing a pre-existing universe. You are actively participating in the creation of your observable reality through your light-mediated interactions. This should be empowering. You are not a meaningless speck in an indifferent cosmos. You are an observer node in a relational web of reality, and your observations matter. They literally help construct the reality you experience. Light connects you to everything within your horizon and encodes your unique perspective on the cosmic boundary. You are, in the most profound sense, co-creating reality with every observation you make. Let's talk about the beginning and the end, because light has something profound to tell us about both. We've mentioned the Big Bang and the cosmic microwave background, but let's really dive into what light reveals about the origin of everything. Before about 380,000 years after the Big Bang, the universe was opaque. It was so hot and dense that matter existed as a plasma of free electrons and atomic nuclei, and photons couldn't travel far before being absorbed and re-emitted. Light was trapped, unable to stream freely through space. The universe was like the inside of a star. But then, as the universe expanded and cooled, electrons and nuclei combined to form atoms in a process called recombination. Suddenly, photons could travel freely. The universe became transparent. This moment is called the surface of last scattering, and the light from this moment is what we see as the cosmic microwave background. That light has been traveling for 13.8 billion years, cooling from thousands of degrees to just 2.7 degrees above absolute zero. But from the photon's perspective, remember, zero time has elapsed. Those photons exist in an eternal now, where the moment of recombination and the moment you observe them are simultaneous. This means, in a very real sense, the Big Bang is still happening from light's perspective. The birth of the universe isn't in the past. It's in an eternal present that light inhabits. And you, observing that light, are connecting yourself to that eternal present. When you look at the cosmic microwave background, you're touching the birth of the universe in a timeless moment mediated by light. But what came before the Big Bang? This is where things get really speculative. But light has clues. The cosmic microwave background isn't perfectly uniform. It has tiny fluctuations, temperature differences of about 1 part in 100,000. These fluctuations are the seeds from which all structure in the universe grew. Galaxies, stars, planets, you, all came from tiny quantum fluctuations in the early universe that were stretched to cosmic scales by inflation. Inflation is a theory proposed by Alan Guth in 1980 that says the universe underwent a period of exponentially rapid expansion in the first fraction of a second after the Big Bang. And here's the key. The fluctuations we see in the cosmic microwave background match precisely what quantum mechanics predicts for vacuum fluctuations during inflation. Light is carrying information about quantum processes from the first instant of existence. This means the largest structures in the universe, superclusters of galaxies spanning hundreds of millions of light years, originated as quantum fluctuations smaller than an atom. And light has preserved the record of that transition from quantum to cosmic. The universe itself is a quantum phenomenon scaled up, and light is the medium that carried quantum information into classical structure. But here's where it gets truly mind-bending. If the universe came from a quantum fluctuation, and if quantum mechanics is fundamentally about information, then the universe came from information. Reality itself, bootstrapped into existence from pure information, and light is the first and primary manifestation of that information taking physical form. Some cosmologists, like Max Tegmark at MIT, have proposed that the universe is literally a mathematical structure, and what we experience as physical reality is just mathematics manifesting. Information, mathematics, and physical reality are the same thing viewed from different perspectives, and light is the bridge between them. Now let's talk about the end. The current evidence suggests the universe will continue expanding forever, eventually reaching a state called heat death, where everything reaches the same temperature and no more work can be done. Stars will all burn out. Black holes will evaporate through Hawking radiation. Eventually, even protons might decay, leaving nothing but a thin soup of photons and other particles getting farther apart forever. But here's the beautiful, haunting part. Those last photons, flying through a cold, empty universe, will still exist in their eternal now. From their perspective, the heat death and the Big Bang are simultaneous. The entire history of the universe, all 100+ trillion years from beginning to end, is one eternal moment to light. And if the holographic principle is correct, all the information about everything that ever happened in the universe is encoded in those final photons. The universe doesn't end. It transforms into pure information carried by light, existing in a timeless state where all of history is preserved eternally. This is Roger Penrose's conformal cyclic cosmology taken to its extreme. Penrose has proposed that the end of one universe might be the beginning of the next, that when the universe reaches heat death and consists only of photons, it becomes equivalent to the state at the Big Bang, and a new universe might emerge. Light is eternal. Matter is temporary. Reality cycles, but light persists. Now, whether any of these cosmological speculations are true, we don't know. But what's clear is that light is revealing reality to be far stranger than we imagined. The universe didn't evolve from simple to complex. It exploded from quantum information into physical form, and it will eventually return to quantum information carried by light. Matter is just a temporary excitation in the eternal dance of light. And you, existing in this brief moment between the Big Bang and heat death, are part of that dance. Your consciousness is light temporarily organized into a pattern complex enough to recognize itself. You came from light. You're made of processes mediated by light, and you'll return to light. You are light experiencing itself from a unique perspective, and that perspective is precious because it's temporary. This should give you a profound appreciation for existence. You are not a random accident in a meaningless cosmos. You are the universe organizing itself to observe itself, and light is the mechanism by which that observation occurs. Every moment of your life is the universe seeing itself through your eyes, and that vision is encoded in light and preserved forever in the structure of reality. Now, let's bring this back to something tangible and explore what all of this means for how you should live your life. Because that's the real question, isn't it? Okay, reality is light, consciousness is light, everything is connected through light. But so what? How does this change anything about your daily existence? Here's how. If observation creates reality, and your observations are mediated by light, then what you pay attention to literally shapes your reality. Not in a mystical law of attraction sense, but in a real physical sense based on quantum mechanics. Your attention directs where your consciousness focuses, which determines which quantum possibilities collapse into your experience. Think about it. Right now, you're reading this? There are countless other things you could be observing. Different words, different screens, different rooms, different people. Each observation is a quantum measurement. Each measurement selects one possibility from many. Your attention is a flashlight beam illuminating one path through the quantum multiverse, and whichever path you illuminate becomes your reality. This means your choices matter profoundly, not because they determine some objective future, but because they determine which branch of the quantum multiverse you experience. Every decision is real, every path is taken, but you only experience one, and your attention determines which one. So the question becomes, what do you want to illuminate with your attention? What reality do you want to experience? Because if light connects you to everything you observe, and if those connections persist through entanglement, then you are constantly weaving yourself into reality through your observations. You're building your own web of connections, and those connections define who you are. This is where mindfulness and meditation suddenly have a physical basis. When you practice paying attention to the present moment, you're literally focusing your quantum measurements on immediate reality, rather than dispersing them through imagination and memory. You're collapsing possibilities into a coherent experience rather than existing in a diffuse superposition of past regrets and future anxieties. And when you pay attention to other people, you're creating entanglement with them, not just metaphorically, but physically, through the light that bounces off them and enters your eyes. You are quantum mechanically connecting with them. That connection is real and persists, so every interaction matters. Every moment of genuine attention you give to another person creates a permanent mark in the structure of reality. This should change how you approach relationships. When someone says, "I see you," they mean it more literally than they know. Seeing someone, really observing them with attention, creates a quantum mechanical connection through light. You become entangled with them. Part of their information structure becomes part of yours and vice versa. Love is entanglement made conscious.